Have you ever wondered how your car manages to turn corners so smoothly without the tires screeching or slipping? The secret lies in a clever device called the differential. In this video, we'll break down what a differential is, why it's essential for your car, and how it works to keep your ride stable and comfortable. Whether you're a car enthusiast or just curious about automotive technology, understanding the differential will give you a new appreciation for the engineering behind every drive. Let's start by exploring the basic function of this important component. When a car turns, the wheels on the outside of the curve have to travel a longer distance than the wheels on the inside. If both wheels were forced to spin at the same speed, the tires would drag or slip, making turns difficult and causing unnecessary wear. The differential solves this problem by allowing each wheel to rotate at different speeds. This simple but ingenious mechanism is what makes smooth, controlled turns possible, no matter the road condition. At its core, a differential is a set of gears housed within the axle assembly. It connects to the drive shaft, which brings power from the engine and splits this power between the two wheels. The main components include the ring gear, pinion gear, side gears, and spider gears. Each part plays a specific role in distributing power and allowing the wheels to spin at different speeds. Let's take a closer look at these components and how they interact. If you drive straight, both wheels need to rotate at the same speed. In this situation, the differential's gears lock together and power flows evenly to both wheels. The drive shaft turns the pinion gear, which spins the ring gear, and both wheels move forward in unison. There's no need for the wheels to rotate at different speeds, so the differential acts as a solid connection between them. As soon as you start turning, the differential comes into play. The spider gears inside the differential allow the side gears and thus the wheels to rotate at different speeds. The outside wheel spins faster to cover more distance while the inside wheel slows down. This action prevents tire scrubbing and ensures a smooth, controlled turn. It's a perfect example of mechanical ingenuity at work. Ring and pinion gears are the first step in transferring power from the drive shaft to the wheels. The pinion gear, attached to the drive shaft, meshes with the ring gear, which is mounted to the differential case. This setup changes the direction of power flow by 90 degrees, sending it out to the wheels. The precision of these gears is crucial for smooth operation and efficient power transfer. Inside the differential case, you'll find the spider gears and side gears. The spider gears are mounted on a cross shaft and can rotate freely. They mesh with the side gears, which are connected to the axle shafts. When turning, the spider gears rotate and allow the side gears to spin at different speeds, letting each wheel move independently as needed. Imagine the gears inside the differential as a small team working together. When the car moves straight, they all spin together. But when you turn, the spider gears start to rotate on their own axis, allowing the side gears to move at different speeds. This teamwork ensures that each wheel gets just the right amount of power and speed for the situation. Most common type of differential is the open differential. It's simple, reliable, and found in most passenger cars. An open differential splits the engine's torque evenly between the two wheels, but it can struggle when one wheel loses traction. In that case, all the power goes to the wheel with the least grip, which can be a drawback in slippery conditions. While open differentials are great for everyday driving, they have their limits. If one wheel is on ice or mud, it can spin freely while the other wheel gets no power. This is why some vehicles use more advanced differentials or traction control systems to help maintain grip in challenging conditions. To overcome the limitations of open differentials, many cars use limited slip differentials, LSDs. These devices use clutches, gears, or fluid to limit the speed difference between the wheels. When one wheel starts to slip, the LSD transfers more power to the wheel with better traction, improving stability and control. Limited slip differentials are especially useful in sports cars and off-road vehicles. By automatically adjusting the torque split, they help maintain grip during hard acceleration, sharp turns, or on slippery surfaces. This means better performance, more safety, and a more enjoyable driving experience no matter the conditions. In front-wheel drive cars, the differential is usually built into the transaxle, combining the transmission and differential in one unit. The principles remain the same, but the packaging is more compact to fit under the hood. This design saves space and weight, making it ideal for smaller vehicles. Rear-wheel drive vehicles typically have the differential mounted at the rear axle. Power travels from the engine through the drive shaft to the differential, which then splits it between the rear wheels. This setup is common in trucks, SUVs, and performance cars, offering strong acceleration and balanced handling. All-wheel drive and four-wheel drive vehicles often use multiple differentials, one for the front axle, one for the rear, and sometimes a center differential. This setup allows power to be distributed to all four wheels, improving traction and control in challenging conditions like snow, mud, or off-road trails. Like any mechanical part, differentials need regular maintenance to stay in top shape. This includes checking and changing the gear oil, listening for unusual noises, and inspecting for leaks. Proper care ensures a long lifespan and smooth operation, so your car can handle every turn with ease. Some common issues with differentials include worn gears, leaking seals, and noisy operation. If you hear whining, grinding, or clunking sounds from your axle, it might be time for a checkup. Addressing problems early can prevent costly repairs and keep your car running smoothly. Modern vehicles are seeing new innovations in differential technology, such as electronic limited slip differentials and torque vectoring systems. These advancements use sensors and computers to actively manage power distribution, offering even better performance and safety in all driving conditions. In motorsports, differentials are fine-tuned for maximum performance. Race cars use advanced types like locking differentials or electronically controlled units to optimize traction and cornering speed. These high-tech systems help drivers push their cars to the limit on the track. As electric vehicles become more popular, differential technology is evolving too. Some electric cars use individual motors for each wheel, eliminating the need for traditional differentials. Others use advanced electronic systems to manage power distribution, paving the way for even more efficient and responsive vehicles. Now you know how a car differential works and why it's such a vital part of automotive engineering. From allowing smooth turns to improving safety and performance, the differential is a true unsung hero beneath your car. Next time you take a corner, remember the clever mechanics working tirelessly to keep your ride smooth and stable. Thanks for joining us on this journey inside the world of differentials.